Hello and welcome to AWS Innovate. My name is Miles Hosford and I'm a Security Solutions Architect. In this session, we are going to be looking at how you can leverage AWS native services to start automating security and compliance in your AWS environment. In terms of agenda, we will look at how you can enforce, assess and remediate security and compliance controls, which will really focus around 5 key services: Identity and Access Management, AWS CloudFormation, AWS Service Catalog, AWS Config Rule, and finally, Amazon CloudWatch Events. So what is compliance and why should we care? Well, the answer to this will be different for every organization. Financial institutions, for example, will need to ensure that they have robust technical security controls in place and follow applicable regulatory guidelines. Many organizations that process credit card data or cardholder payment data will need to be compliant with the PCI DSS standards, and for certain organizations, there may be country-specific law to comply with around the use of personal data and user privacy. When we start thinking about automating compliance, there are really 3 areas that we need to consider: enforcing, assessing, and remediating. In terms of enforcing compliance, we have a number of services that can help you. Firstly, AWS Identity and Access Management, which allows you to create users, groups, and roles, prevents users accessing functionality that is out of their job remit in the first place. By adopting the principles of least privilege and segregations of duties, your users should only be able to access services and functionality that they are permitted to do so as part of their role. You can then use AWS CloudFormation to create templates of your environment that already define your desired security controls. A great idea is to get these CloudFormation templates approved by your internal stakeholders, such as cybersecurity, risk and compliance, and technology leads, to reduce the time it takes to deploy to production in your organization. Step 3 in enforcing a strong security and compliance posture is to use AWS Service Catalog to provide your internal users a list of pre-approved CloudFormation templates that can be launched in a self-service nature. In terms of assessing compliance, we have a number of services that can help you. AWS CloudTrail allows you to log and continuously monitor events related to API calls across your AWS infrastructure. CloudTrail provides a history of API calls that can be used to determine who made changes or access specific functionality within your account. AWS Config is a service that enables you to assess, audit, and evaluate the configurations of your AWS resources. Config continuously monitors and records your AWS resource configurations and allows you to automate the evaluation of resources against your organization's security policy. Amazon CloudWatch Events can be used to deliver a near real-time stream of system events to AWS Lambda. CloudWatch Events becomes aware of operational changes as they occur, allowing you to take corrective actions as necessary by sending messages to respond to the environment, activating functions, making changes, and capturing state information. For example, the moment a resource changes state to non-compliant, you can execute a Lambda function in response that automatically remediates. If a developer changes a security group that exposes a server to the internet, Lambda can automatically revert the change. So let's dive deeper and discuss how to get started enforcing compliance. AWS Identity and Access Management allows you to create users and assign them to groups that map to your organization's job functions. Each group should be given permissions that only allows users to execute functionality required by their role. Let's take a brief look at a number of best practices. One of the first things to do is ensure you create individual users in IAM for your staff. Sharing accounts and credentials is a bad security practice and lacks accountability for any actions performed. You have no clear visibility into who within your organization performed what operation. Once individual IAM users have been set up, the root account should be locked down and not used for everyday tasks. It is also important to ensure you enable multi-factor authentication for privileged accounts. Users within your organization should only be given the permission that they require to execute their role. For example, you may have a security team that is required to make changes to AWS security groups to allow inbound TCP traffic. Only the security team role will be provided the necessary permissions to perform this function. Your storage team, however, may not require the ability to modify network settings such as security groups, and as a result, their role may only allow modification to Amazon S3 or simple storage service. To summarize, using IAM will allow you to prevent misconfigurations or non-compliant resources being deployed in the first place as part of a defense in-depth strategy. AWS CloudFormation is where things start to get interesting. As I previously mentioned, you can create a template that contains your desired configuration, and you can enforce that template to be used by your users. Let's take an example. If you are processing credit card data and need to be compliant with PCI DSS, there will be a requirement around the use of encryption that you must adhere to. Within your CloudFormation template, you can specify the use of encryption for your EBS volumes so that when your developers deploy infrastructure, these controls are already built in. CloudFormation templates can be built in JSON or YAML and are basically text representations of your desired environment state. The controls that you define will be visible to your security team, auditors, and other stakeholders that allow them to verify they exist. The template is a representation of your environment before anything is even deployed. This allows you to identify misconfigurations before you deploy any infrastructure. Let's take a look at an example. On the screen, you can see a simple 3-tier web application that implements some basic security controls. There is login, security groups, multi-AZ databases, and encryption using KMS. After discussing this architecture with your internal stakeholders and getting approval for deployment, you can represent this target state as a CloudFormation template and save it for future uses. This becomes your golden blueprint. The next time you want to build an application or deploy a test environment, you can launch the template to rebuild the desired state, knowing that your security compliance controls are already accounted for. So what does this look like? On the slide, you can see a sample CloudFormation template. This is a textual representation of an environment, like the architecture we just discussed. The template can be used to pre-configure security controls such as security groups, networking, encryption, login and monitoring, and so on. Let's dive into an example. This is an example of a security group, AWS's stateful host-based firewalls. And looking at the description, we can see that this is intended to be used by servers in the private subnet. Because we have the ability to parse this template before resources are built, we have the power to find misconfigurations. For example, we can see that the source IP of the private connection is from any IP on the internet. This is undesirable and something you may want to avoid. We can also see that the telnet protocol is allowed, which may be another misconfiguration, as it is a clear text protocol with a history of vulnerabilities. These two misconfigurations can be detected before any infrastructure is deployed, preventing security issues in your environment. So where does Service Catalog come in? To start, it allows you to create a catalog of products or services that are approved by your organization and make them available via self-service portal. These products are based upon CloudFormation templates and allow users to quickly deploy the approved templates or IT services they require in a self-service manner. For your security and compliance teams, this gives you the ability to have control standardization through the approved templates, and for your users, it allows agility and a faster time to market. Let's go over to a demo and show you how this works. So this is an example of a CloudFormation template which represents a web application that can be used by my organization. The template already contains the controls that meet my security and compliance requirements, and I benefit from those controls by simply launching the template. An additional benefit of CloudFormation is the ability to pass parameters into the template at launch time. As you can see, I have parameters for application criticality, information classification, and the environment type. This gives my users flexibility to use approved blueprints, but customized to their specific requirements. For example, if the information classification was highly confidential, the CloudFormation template can ensure additional controls are in place to protect that data. For non-sensitive workloads, the control requirements may differ. Moving over to the AWS console, we jump into Service Catalog. You can see I have a number of portfolios. Each portfolio can contain different products which are backed by CloudFormation templates. Let's go ahead and create my new secure application product. I give it a name and a description, and I'll go ahead and upload the CloudFormation template that I just showed you. Okay, my product is now added to the portfolio. Let's take a look how this would look for an end user. So I go into the product list, and you can now see my application is listed. Let's launch this product. Now this is where the parameters from my template come in. As you can see, my users have the ability to customize the template and provide application or business values. These values can be used within the template as conditions to ensure appropriate controls are in place. When I am ready, I launch the product, and Service Catalog goes ahead and deploys my resources. My security controls are already present, and I benefited from the agility of Service Catalog to provision my application. So, we just discussed how you can start thinking about enforcing compliance with IAM, CloudFormation, and Service Catalog. Let's take a look at how you can assess your environment to determine if you are compliant with the controls you have specified in the first instance. I'm sure everyone is familiar with IT security policies. Most organizations have them. They lay down the control requirements and guidelines that should be followed. The problem with IT security policies that are static or paper-based is that it is difficult to ensure your staff read them, and it is difficult to ensure the controls are implemented. Policies like this tend not to get updated too often, maybe annually, but they don't move as fast as the rest of your technology stack. AWS Config Rules is a service that allows you to codify your IT security and compliance requirements. You can take each discrete requirement from your financial regulators like MAS in Singapore, PCI DSS requirements, or internal controls, and turn them into rules that run in near real time to detect non-compliance. This is an example of Config Rules dashboard, and you can see a number of rules that are enabled in my account. These rules are continuously running and will respond to changes and resources in near real time. These rules can be aligned to external compliance requirements or your internal controls, and can be part of your CloudFormation templates to ensure users are only deploying compliant resources. So how do you get config rules? Well, we have the concept of a managed rule, which has been created by AWS. These rules cover common control requirements you may have. For example, encryption. We have a managed rule that can detect if EBS volumes are using encryption and will flag any volumes that are not encrypted. We have managed rules that can detect if the root account is using multi-factor authentication or if security groups are allowing traffic from any IP address on the internet. We also support the idea of custom rules, which allow you to create your own business logic to determine if a resource is compliant or not compliant. Custom rules are Lambda functions, and by taking a look at this example, you can see on lines 8 and 9 we have an evaluate compliance function. This is where you could code in your custom rule logic. On line 23, we actually submit the result of the compliance check to the AWS config service to be represented by the dashboard. Let's take a look at this in practice. On the left, we have our compliance requirements, which may come from financial regulations or other frameworks. So for the confidential information requirement, we have a managed rule that can be enabled to detect if EBS volumes are encrypted. For the requirement to detect where the baseline standards are applied to operating systems, we have a managed rule that can detect if approved Amazon machine images are being used. For the final requirement and the ability to perform network monitoring, we do not have a managed rule, and a custom rule will need to be created. Let's jump over to the demo and show you how this can be done. This is the AWS config dashboard. I currently have no rules running, so let's go ahead and set some up. The first rule I want to create is to detect whether my EC2 instances are using encryption for the EBS volumes. I can change the name of the managed rule, and I also have the option to specify a KMS key, and I go ahead and click Save. That rule is now evaluating the resources in my account to find out if I am compliant or not. Let's quickly create another managed rule to detect whether my operating systems are being launched from approved Amazon machine images. I specify AMI 12345 as the approved AMI, and I click Save. For the final rule, I want to detect whether VPCs have flow logs enabled. This logic will be performed by Lambda, which I have already created. Jumping over to Lambda, I can copy the ARN of this function, but taking a quick look at the code, you can see a trivial check to detect whether flow logs are enabled for my VPCs. Going back to the rule, I complete the setup, and I choose a periodic trigger to run the rule every hour. In the short time it took me to set up the 3 rules, you can see that the first 2 have already completed their initial evaluation and have returned some non-compliant resources. I can now dive into the detail of this rule using AWS config to determine what the resource is and when the changes were made that resulted in the non-compliance in the first place. This gives me ongoing continuous visibility into the compliance status of my environment. How do you actually automate the remediation of non-compliance? If AWS config is detecting non-compliant resources, what are the next steps? I'm going to discuss two methods, continuous remediation and periodic polling. Let's get started with the continuous. Let's assume your users are making changes to resources within your environment. These changes are sent to the AWS config service, where they are evaluated against the rules you have enabled for your account. You can then stream these changes and compliance notifications to Amazon SNS and subscribe to the SNS topic using Lambda. Using Lambda, you can respond in near real time by executing functions and API calls to remediate non-compliant resources. An example may be to simply notify the security team that something is non-compliant, or you may wish to take remediating action, such as terminating EC2 instances that have been launched in a non-compliant configuration. Let's take a look at periodic polling. So you have your users making changes to your environment, which may result in non-compliant state being detected by AWS config. Instead of sending that to SNS, you may want to periodic poll AWS config yourself from Lambda to create weekly or monthly risk reports or to perform trend analysis and gather metrics. You still have the ability to perform automated remediation, but this is more of a polling approach rather than streaming in real time. I have created a simple Lambda function that will poll the AWS config service to detect which resources are non-compliant. In this example, I am just looking at the encryption config rule created earlier. I will also send the details to my Slack security operations channel to highlight the real-time nature of this automation. So I go back to Lambda, and for the trigger, I want to select the CloudWatch event schedule. You can think of this as cron in the cloud, a service that allows me to fire my Lambda function on predefined frequencies. For this rule, I select 1 minute and I click Save. I now have my Lambda function polling AWS config every minute. I now wait for my CloudWatch schedule to trigger and poll the config service. When it does, it will detect the non-compliant resources and notify my security operations channel. Here we go. The Lambda function has polled the AWS config service and my Slack channel has been notified. Within the Lambda function, we have the ability to auto-respond by terminating EC2 instances for our example. I just demonstrated how you can respond to non-compliant notifications within your environment using AWS config rules and Lambda. How do you automate response to security events that are not necessarily a complete change in state, but maybe API calls or actions within your environment? Amazon CloudWatch Events allows you to monitor for API activity within your account and react to malicious behavior or security misconfigurations in near real time without having to involve an operator. Using Amazon CloudWatch Events, you can monitor your AWS environment for specific API calls, such as CloudTrail stop login, and respond automatically with the Lambda function. Let's take a look at two examples. Firstly, you might want to know the moment someone turns off CloudTrail and automatically turn it back on. Another example may be if someone changes a production security group and exposes a server to the internet. You may want to revert that change. So let's assume one of your developers turns off CloudTrail. This may be accidental or potentially malicious behavior. Either way, the stop login API call is executed. You would have a CloudWatch event set up to monitor for the stop login API call with an event source as the CloudTrail service itself. The CloudWatch event target would be a Lambda function that automatically responds and takes mitigating action. In this example, that would be to enable CloudTrail and possibly assign an IAM deny policy to the user to prevent further malicious activity. Let's take another example where a user modifies your production security group and exposes a server to the internet. Just like the previous example, you would set up a CloudWatch event that monitors for a specific API call. This time, it will be the EC2 authorized security group ingress that is executed. In response to the event, your Lambda function would parse the event, determine if this was a production security group, and if applicable, revert the change. The mitigations for these examples happen in near real time without the need to involve an operator or human staff. Let's take a look at a demo of how you would set that up in practice. We start with the CloudWatch Events console and we need to create the rule. We choose the CloudTrail service and specify the stop login API call. You can see a sample of the event pattern below. For the target, I select Security CloudTrail Lambda function, which I have pre-created, and I finalize the details of the CloudWatch event. Taking a look at the Lambda function, you can see on line 26 and 27, I perform a simple check to detect if the stop login event has been executed. And in response, I make the start login API call to turn CloudTrail back on. Jumping over to CloudTrail, you can see my master logs trail is enabled. Let's go ahead and turn it off, simulate a malicious attacker. Okay, so CloudWatch events are triggered in around 30 to 40 seconds after the API call has been made, or sometimes sooner. So let's just hang out in the Slack channel and see what happens. There we go. We got notified that CloudTrail was stopped, but we have already automatically mitigated this issue using CloudWatch events and the Lambda responder. Let's go back to CloudTrail to verify. Okay, we can see that CloudTrail is indeed enabled and monitoring API calls within our environment. In our second example, we want to detect if production security groups get changed and automatically revert those changes. We follow the same process, create a rule, but this time we select the EC2 service and specify the API call as authorized security group ingress. For the trigger, we use a Lambda function that will auto-revert the security group change, and we finalize the details. Taking a look at the Lambda function, you can see on line 22, we check if it is our production security group. And if so, we go ahead and call the revoke security group ingress API to revert the change. Let's go ahead and give this a try. Moving over to the console, we select our production security group, and we want to go ahead and add SSH and make it open to any source IP address on the internet. Let's wait for the event to fire and be notified in our security operations channel. We can now see our notification informing us that the security group was changed, but it has already been reverted to a known good state. The Lambda responder has performed the automation. Going back to our console, we can now see that the SSH inbound rule for the production security group no longer exists. Using this sort of automation will allow you to scale your security operations and automatically respond to malicious activity within your environment. Okay. So we've discussed how you can use AWS services such as CloudFormation, Service Catalog, and config rules to enforce, assess, and remediate compliance in your environment in an automated way. Here are some key takeaways. Use IAM to restrict users to perform functions required by their job function. Adopt the principles of least privilege. Use CloudFormation and Service Catalog to design and deploy compliant resources with your key controls baked in. Perform continuous compliance. Architect your environment so that you can detect non-compliance in near real time. Use services like AWS config rules to help you automate and scale your security controls. Automate your remediation using Lambda. This will allow you to improve consistency in your processes and lower the target time to remediation. If after today you are wanting to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, remember to validate your technical expertise with AWS certification. This brings me to the end of my session. I hope you found it useful. Do remember to provide feedback on today's event so that we can improve the event experience for you in the future. With that, I would like to thank you for attending AWS Innovate. Please enjoy the rest of the conference.